All right, good evening, folks. This is Paul Thompson with the Severe Weather Network, and we are looking at a live weather system that is going on tonight. It looks like it is pretty bad with some of these thunderstorms here. Looking at current conditions, you can see the severe thunderstorm warning right here. A little bit of inflow notching that's going on in there. This is going to bring with it a lot of really heavy winds, really heavy rains, really heavy hails. Definitely going to bring some trees and power lines down, as well as flash flooding is definitely going to be one of the larger threats as well. You can see all the lightning that's in this, accompanied with this as well. A lot of cloud to ground lightning could be possible with this as well. So a lot of threats going around tonight, as well as so for the winds. These systems here kind of look like a lot of really hard straight line wind systems that we get brushing across because of this kind of huge bowing feature that these storms have. Anytime that you see these big bowing kind of features to them, they usually bring a lot of wind shear with them. Also, obviously, tornadoes are always going to be a threat here with a system like this. Got a lot of southerly winds coming in with the advection, as well as the westerlies also coming in there. It's going to cause a lot of supercell development spin up. So anytime that you get these bowing features here, it's going to cause a lot of wind shear. So a lot of wind is going to be coming around. Definitely going to blow some items around the yard. Could do possible damage to some things flying around, and everything might hit your car or your windows and things like that. So just be mindful of that. Not really the kind of weather you want to be out on the highway or on the road with. So I know everybody's got stuff to take care of, but man, as soon as you can get home and get to your to a safe location with your family, definitely get that done. So, 'cause this is one of those days where you really got to adhere to the warnings. All right, so with all this, a lot of the storms that are going to be coming through here tonight, I hate to say it, are only kind of an initial setup for tomorrow's convection setup. So we're going to be looking at that. And that's the reason I really wanted to get to this video, to cover the storms for tomorrow. This is the convection outlook for tomorrow. I didn't check NATOcast today, but NATOcast is usually tracking this stuff early. I do got to check that out because NATOcast surprisingly is pretty accurate most of the time as far as the tornado threats go. Alright, so this convection outlook has actually been updated, from the last time that I looked at it, because there is a 10% risk going up into the Ohio Valley for that tornado risk, which earlier today when I looked at it, it was only the 5% risk. Now it's been upgraded to that 10% risk. The hatched areas were always there right from the beginning when they rolled out the convection outlook, as far as I've seen it. So the hatched in areas just basically means that it says intensity here. You know what I mean? They got all these new areas, but usually the hatched area just means that you have an additional risk for tornadoes within 5 miles or of any point here. All right, so these are pretty threatening, even down here in Texas where you got this 5% risk, and then the hatched in area. First of all, Texas is notorious for hail makers. So anytime you get storms down there, because of the abundant moisture coming off of the Gulf with the advection and everything, hail is really prevalent in Texas. It always has been. Anybody who's lived in Texas, when you get these storms, the sky just turns green, and it's a nasty looking green, and then you get hail, then you get your thunderstorms, sometimes tornadoes accompanied with it. The green is synonymous with hail, not synonymous with tornadoes, but sometimes, most of the time, the two accompany each other. All right, so even with the 5% risk in Texas, and most of all of what we've seen of the storms this year so far in this early going storm system, that 5% risk is meager at best and really doesn't mean a whole lot. You still could get some really substantial storms out of this with really serious stuff like tornadoes, like big tornadoes, like we saw in Michigan with that 5% risk up there. It ended up, laying down a pretty nice, decent tornado that did a lot of damage, took some lives, injured some people, very, very serious stuff. So I'm taking a 5% risk with a grain of salt because I don't know exactly what we're looking at here. All right, so let's go ahead, and I already jumped it over to the high resolution model, which is my favorite model. I like to look at the high resolution model. It's definitely a good model to go with. 3 days out, anyways. I can't really see with the high resolution model beyond 3 days out. Then I look at the GFS just to look at what might be possible in the areas that are going to be affected, so that I could kind of apply that to the high resolution model when I go and look at it later on. All right, so as usual, I'm going to jump over to the I'm going to jump over to the composite reflectivity here. All right, so we're going to start down here in the south. I'm going to work my way up because the more serious threat based on the convection outlook is in the north in the Ohio Valley. So, all right, so we are looking at tomorrow. So right now I'm at the 7 p.m. Time frame. This is midnight. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now you get a little bit of these prefrontals that start up. This is kind of the show before the show. You know what I mean? You get some of these storms that are going to come up, and they might fool you a little bit, like, oh, this isn't that bad, just because it says marginal severe. Got a little bit of significant hail that's already starting up early in the day, 7, 8 o'clock, 10 o'clock in the morning. And then you can see the big gap right there. This is a real nice break in the caps right here. All right, 74 degrees, 63 in dew points, which is pretty substantial. It's pretty wet, it's humid, it's hot. Going to have some of that muggy stuff. A little bit of that veering winds that's going on. Lifting condensation levels coming down. This blue thing right here is our cloud level. So cloud level is going to be real low. All right, so if anything gets spinning up later on, typically you might see it if it's going to happen during the day. That doesn't mean go looking for it. Alright, so the ship is at 1.1, pretty substantial hail, which we've already established over here in the analogs. And Texas, Texas is known for hail makers. So you start getting some of that hail. Some of that hail could be on the larger side, so please get under cover if you see some of that hail, because it can hurt you. Alright, so moving on. Alright, we're looking at the afternoon. 3, 4 o'clock, you start to see these lines that are going to be popping up off the panhandle here, which I kind of like to call it the scar. This is kind of the dry line right here. These storms move across this panhandle border line right here, and I call it the scar because it's like a line that actually follows the Midwest states all the way up to pretty much Nebraska. And as soon as the storms kind of come across that line, they get out of the dry area of the country. They start to move into more buoyant atmospheres. And then your caps start breaking. And once your caps start breaking, those storms start to really organize and start to get severe because they're in more buoyant, wet, heat, moisture, nasty, unstable environments. All right, so that's kind of what we're seeing here. Is that they're moving across that panhandle line right there, and then they're coming across here. They start to jump up in extremity, and they start to get severe here. So we're going to pop it just to the east here. You start to see that big, huge break in the caps. 52 in dew points, just kind of getting going. 78 in temperatures, 79 in temperatures. Pretty warm temperatures right there. You can see that difference in the cloud level right there. So this is kind of, but look at our wind right here. Our wind is 71, 75 knots of wind shear. Again, a lot of wind shear that's in here. Lots of wind shear. That wind shear is going to contribute to right moving cells. It's going to contribute to spin up. It's going to contribute to rotation, and definitely the possibility of tornadoes. Right now, we're early in the game in this sounding. Hasn't really gotten going yet. Hasn't really gotten organized. It's going to take some time. To be honest, these are probably not the ones you're going to worry about. But all this crap that's over here on the west, once it starts to move, across that line that I was talking about, then you're going to start to see some of that organization really, really ramp up ahead of the cold front that's going to be coming. This is probably going to have a kind of a trailing off or a leading warm front that's going to be coming up there. It's going to be trapping a lot of that heat, moisture, and advection that's going to be coming in. So let's take a look at our dew points and wind barbs here for a second. All right, so right here you can see that, you know what I mean? You can see where the temperatures are a little bit drier out here. It's not as substantial, but you can see over the Gulf of Mexico, the southerlies coming up. Really crazy plume of moisture that's coming up to the Gulf, through the Gulf of Mexico into this area of Texas here. So these storms are going to move in there. It's already going to be wet enough and buoyant enough for them to really get some energy going. All right, our temperature here. Yeah, you can see these hot temperatures that are moving up here. You got westerlies that are going to be coming off of this area here into this kind of big, humongous, unstable air mass of heat and moisture. Really, really hot temperatures. Look at that. 90s up here. You got, up in the 80s going up into parts of the panhandle of Texas and Oklahoma. 80s down here as well. All this heat and all the and then all the moisture from the dew point that we saw here, that's going to really make for an unstable environment. All these storms are going to move in. They're really going to jump up in extremity and really start ramping up. All right, so let's go ahead and take it a little bit further, see how these cells develop here. As they get into the central Texas region, then I can see this kind of area right here starting to look pretty alarming, to be honest with you. See these little tiny cells that are coming off of the ocean right here? As soon as they get into Texas, they start to kind of drip off of this and start to renegade here. And once they do, you can see these features right here, these two cells especially, they're, textbook structure. Really looking nasty. Really looking nasty. So if we pop it just kind of to the northeast here, you can already see we're getting a pretty decent tornado structure looking off of the data right here. Look at the lapse rates of 700 to 500 millibar at 8.6. That's some of the highest lapse rates that I've seen, especially in what is considered a low-end tornado threat. When our helicity, we have a helicity here at 3 kilometer over 2.4, and our effective inflow is already almost at 2. Hailmakers are out at 1.6 on the ship. All right, STP is up over 1. Our supercell development is 6.1. I mean, I don't care what this thing says here as far as the S2P effective layer here. It looks like normally I would say it's a lower end tornado threat, but with everything that's kind of been happening this year, with the way these setups have been coming together, this is not what I would consider a low end threat. I think that this is substantial enough to make a big enough storm that would be able to run off with the energy, that this is a chance you could have a decent sized tornado out of it. At least one. If not, you're going to have a pretty decent sized severe thunderstorm that's going to be able to really hammer a punch. Northeast facing forward flanking downdraft hydrograph structure here with that hooking structure. That's a really decent looking hydrograph as far as storm structure is concerned. You got a big kind of wide curving on this slinky here. All right, storm slinkies kind of when it's consistent with what it's saying up here, I'm usually tend to believe that there isn't a whole lot of disturbances in here, kind of mixing up and messing up the measurement. Our wind here on the ground, you can see this lower end wind shear that's down here. There's a little bit of veering winds right here around probably 1.5, maybe 2 kilometers, somewhere in there. But I don't think it's gonna, affect the wind shear enough with those veering winds to be able to limit any storm potential at all. Not on a day like this. LCL is low enough, 63 in dew points, is 74 degrees. And temperatures, look at our wind shear here, 65 knots to 85 knots up to 3 kilometers. You know what I mean? That's what the data is saying, so you're going to have some really substantial winds coming across there. And that wind shear that's really all you need. With everything else that's in this area, that wind shear is exactly what you need for these storms to really get ramped up, really get severe, be able to drop tornadoes. All right, off to the so that I'm looking at just to the east and northeast of that cell behind that original front cell. Let me pop this again. So I was looking at the sounding we just looked at was this cell right here in the front, and now we're looking at this one off to the west behind it, and then we get a big fat nasty tornado sounding like this. Same thing with the hydrograph, really nice hydrograph structure, big hooking structure right there. Storm Slinky's reading it too. So those are both consistent with a nice hooking structure in there That's really substantial for those rotating cells to really get going. That kind of lets you know you're going to have some serious rotation going on. Supercell development here is significant at 11.8. This isn't the highest that I've seen as far as supercell development, but on a day like this, it doesn't really have to be. You know what I mean? You have a lot of wind shear that's in here. Look at this, 52 to 66 knots of wind shear. It's more than enough that you need to get any kind of spin up in there with enough inflow. It looks like inflow 3.7 on helicity readings here. 4.0 3-kilometer helicity. That's a lot of energy that's being whipped around here. Lapse rates are a little lower on this, but they're still reading unstable environment. That's all it tells me, unstable environment. With the CAPE up at 1900 joules to 2400, 1900 for most unstable CAPE. Alright, so definitely a lot of instability being chucked around here with some really, really substantial heavy winds and high temperatures, high dew points. It's looking like a tornado day, unfortunately. Now, early on, as these cells are getting going here, you might have the same thing here where two of them are next to each other like that. The possibility of both of them dropping tornadoes, I guess it's there, but it's probably meager. It's a small window of possibility. Really, what I think might happen is that those two are going to kind of struggle for energy. They're going to fight each other. That might kind of happen there, where they're going to fight each other for energy. We'll see in the next frame when we cut it forward an hour and see what happens with those two cells. I'm assuming that they're going to converge because one's going to kind of take power from the other one and starve it and suffocate it. It could be the one further off to the southwest. It could be the one to the northeast. We don't really know. So we'll see. But these cells off to the west here on the back of the line probably, are going to be a little bit more severe. They always are on the back of the line. That's where you get the really, really big guys, those kind of frontal cells. Sometimes, you know what I mean, they'll get going, they'll drop some tornadoes and everything like that, but they might be short-lived. These big guys, these big serious cells off to the west on the back of the line, I've always tend to find are a little bit more extreme. Like this is just like the prefab demo here, you know what I mean, with these cells off to the east and northeast. Then you get this back of the line where these cells are converging, coming together, making actually like a squall line of cells coming together. Those ones are usually the ones that are going to have a really nice punch to them. And that's kind of what we're seeing here, 81 degrees in temperature. You can see that temperature jumps up, you know what I mean, almost like a full 10 degrees almost, 63 in dew points. The dew points are kind of holding steady. Again, the advection that's moving in, I mean, the dew point doesn't have to be really crazy. It doesn't have to be, 70 point dew point here. And it's already wet, it's already unstable, there's already enough CAPE here. You can see the surface CAPE at 2300 joules at CAPE. Most unstable CAPE's reading at 2300. Pretty much it's the same thing. All right, lapse rates jumped up again here in the back of the line, in the sevens of lapse rates, 500, 700 millibar. All right, significant tornado parameters, both are up over 2.0. Supercell development at 13.6. So what the numbers tell me, this is a really big storm, really strong, lots of power, lots of rotation, and lots of potential for tornadoes. All right, ship at 1.6. Very potential for those tornadoes to drop some gorilla hail, some big, big ice hail. All right, so we're looking, with it reading at 3, I would say at least 1.5 inches in diameter. You know what I mean? Is possible. So you could see some golf balls, probably up to baseball size hail sometimes. I think that's possible. So let's see what else we got here. 69 to 72 knots in wind shear, looking all the way up to 6 kilometer to 8 kilometer. So we're looking way high up in the atmosphere, but how this works is that what's happening up here at the top of the storm, that's going to filter kind of down, so if it's rotating real hard way up there at 50, 60,000 feet in the atmosphere, that whole thing is going to get spinning like that all the way down to the bottom of the mesocyclone, and that's where you're going to get your biggest potential, that low pressure reaching the ground and that tornado being able to actually touch the ground. it's very, very favorable for something like that on a day like this, especially with that kind of wind shear that's going on. All right, so that's why they say surface to 6 kilometer. You know, it's a big window for you to be able to see, because if we're looking at surface right here at 0 kilometer, 6 kilometers up here, you know, you're looking, you know, 15, 20, 25,000 feet is kind of where we're looking at, where that rotation and that wind is really kicking up there, and then being able to filter that all the way down to the surface of the ground. But the point is, tons of wind shear here, tons of helicity, which is just telling me the entire atmosphere in this region is just charged like a battery full of energy for these storms to really pack a punch. All right, so 4.6 surface to 3 kilometer helicity here, 4.3 on the inflow, which means that we have a really nice stable updraft, nice stable inflow. That southern advection with those southerlies are going in there, meshing with those westerlies, being able to cause a lot of rotation. So it's really kicking up. It's kicking up nicely for storm chasers, bad for everybody else. Hate to say that way, but that's kind of the case here. All right, so let's go to the next frame. Just like I said, that frontal cell right there where we were looking at these two cells converged and made one big nasty looking cell. So we pop that just to the east. Still looks like a lower end tornado threat. And again, this is probably because it's in the front of that squall line of storms. Still has a pretty nice structure as far as storms go that could become tornadic. But these storms that drop tornadoes like this, when they're in the front of the line, they might drop a smaller end tornado, you know what I mean? Like these, you know, tornadoes that are thin, still pretty violent winds, still can kill you, but they only last like, you know, a few miles, then they dissipate because usually their energy is being taken from another storm. Either this one here to the north right here, as this line right here off to the north is starting to converge with that far western line, they start to come together. So that far western line that was stronger an hour before that we were seeing is going to start to take helicity and energy from these other storms off to the east right there. They're going to start choking them out. And once they do that, they're going to absorb that energy, and then you're going to have these cells start to reorganize. That's where you're going to get into that recycling process again. So any storms there, they're going to temporarily go through kind of a pause period while they're trying to collect all that energy. They go through that period of recycling, reorganization, and then that's at that point when they're able to really, really romp out a pretty nice, decent storm here. Now, this hour here, when we were seeing the merging happening with those two frontal cells off to the northeast, all right, this was 7 p.m. tomorrow night. Yep, 7 p.m. tomorrow night. All right, so 8 o'clock, we're looking at 8 p.m. 8 p.m. we're looking at is when we're going to start to see that converge happen. So where it looks like, okay, things might be dialing down a little bit, it might be, you know, not that bad, don't fall for that. I'm telling you right now. Because when they're going through these kind of null periods of where they're paused, they're starting to reorganize. It might seem like, oh, it's just, you know, a bad thunderstorm, no big deal, a little bit of lightning that we're going to have with this. You can see these cells embedded in here in this upper line right here. Get a little bit of a linear effect, almost like almost putting together, almost sort of QLCS-like a little bit. But I'm not really sure if it's going to be like that. But even here, we're getting some lower end tornado threats with it. Same kind of look on the hydrograph with the big hooking structure right there. We're also getting some helicity in here, some hail threats. The same kind of look we are seeing off to the south. So what this tells me is that we have plenty enough advection coming off of the Gulf of Mexico running into this line, which kind of causes QLCS, which is a quasi-linear convective system. All right. And so that's where you get these little lines. You kind of see these lines in here. And then inside there is just boop, 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 like Morse code, like dots going up the storm. You see all these little embedded cells that are kind of hidden in that line. All right, so anywhere in there you can get these kind of microbursts, these little, you know, isolated tornadoes that are hidden in that line of storms. So, but one thing is for sure, it's also going to carry with it some really, really heavy winds. You can see all the bluing out in front of it. Torrential rainfall is going to be definitely something that's going to be that you're going to have to watch for here. flash flooding, a lot of lightning, possibly cloud to ground lightning, and some damaging hail is definitely going to be in this line coming with it. Now, if we move off to the south end of the line, you get these big beefy cells in here. Now, these are going to be your big problem makers as far as the tornado threat. If we pop it off northeast to the northern end of that line, then you can see that we're already getting tornado threats that are a little bit more substantial in severity. All right, our CIN is reading at 2.0, while our fix is a little bit down. I tend to trust the CIN a little bit more. I think it's a little bit more accurate to the reality of the situation, so I would definitely take that into consideration, that our supercell here at this point is 8.0, our significant tornado perimeter at 2.0. All right, so which is pretty high. Lapse rates at 500 millibar, looking at 7.3. It's definitely substantial enough. Now our CAPE is kind of fooling us here a little bit, and what I'm thinking now, after looking at the CAPE, some of the helicity isn't really there yet. I think that this cell is a little bit early in its development. I don't really think it's there yet, and I think it's that converge that I was talking about. There's a lot of converging, a lot of mixing going on where it's absorbing and taking a lot of power from those other far northeastern cells, and that whole line is kind of coming together. So as it's doing that, then you're going to get readings that are, I like to call them off readings, because they're not because they're temporary. You know what I'm saying? So if you look an hour later at the same exact cell, you could get a reading that looks exact. You can get a sounding that looks totally different than the one that you just saw an hour before. And it's only because of that converging and that changing. Every time that they absorb another storm, then they got to rebuild and recycle and they got to reorganize all over again right from the beginning. All right, but here in this area, you get a little bit of notching, and you get this big, huge bowing section right here. And this bowing section doesn't have a whole lot of bluing out in front of it. So the one thing that's going to be substantial with this, and if I can zoom in on this a little bit, I can show you. But you see how sharp that edge is right there? That kind of tells me that you're going to have some really hard straight line winds that are going to come with that bowing section up to that area. And as it kind of continues along, all right, so definitely have everything kind of, batten down the hatches for this thing to come along, because it's going to blow some things around. All right, don't be outside for that too, because if it does take off some shingles or siding on a house or something like that, those things are going to be flying through the air at some pretty substantial speeds. They could cause some injuries and do some damage, stuff like that. So that's the kind of winds that we're looking at right in there. You can see another kind of notch right there where the other cell off to the south is. All right, so this one's just kind of getting going as they're coming into the line. So this is that period of, they're trying to reorganize. All right, so now that line is starting to come together. It's starting to converge. Let's look at kind of the same point here as these are all coming together. All right, so you can see the tornado threat's a little bit higher. It says marginal tornado threat, and I think that's I think that might be short-lived. And you can see here the lapse rates is 700 to 500 millibar, 8.3. That's pretty high for lapse rates at 500 millibar, and that might coincide with what I was talking about earlier, where they're kind of absorbing energy. That energy is now being applied. It's now being put to those storms, and that's where you get that boost in energy. It's just like, a guy that takes an energy drink and just starts running. Woo! I'm going! I'm charged! That's what these storms are doing. It's just kind of like nitroglycerin for, these storms, just boosting them up. You see the helicity right here at 2.2, 2.0 and inflow. So that's that burst of energy. The storm has got it. It's ready to go. So we're going to see in the next hour some of that development that's going to go out. It's going to charge up that storm and really get it going. Off to the south of that line, let's look at the southern portion of that line. I do spike a little bit of Omega there. Got the wind doing a couple of different things. Let's look a little bit south of that. All right, so down here, there's not a whole lot of organization, because I think we're too close to Mexico at that point. All this advection is coming in here. So this area here, these storms come up off of Mexico, and with it, they're bringing a lot of heat. and then the moisture kind of comes in there with the advection that's coming off of the Gulf of Mexico. It takes a little bit for these storms to run into Texas before they really get started here. So that's why right around this region here, which typically with most states that get tornadoes, the center of the state is probably the one place where, especially in the southeast, Texas, some of the Midwestern states, it's where you see a lot of that collection, that organization actually happening. It's probably one of the worst places to be, just because of all that organization. That's where all these, the center of the states of these states, man, it's like the hangout zones for tornadoes. It really is. All right, so let's look an hour later here. We're looking at about 10 p.m. And you can see a little bit of a linear effect here, setting up like a QLCS now, with a lot of a really notchy line. Some sections here bringing a lot of possible straight line winds, a lot of torrential rainfall, and possibly some tornadoes. Now the northern line is starting to actually come down a little bit. It's still strong, still plenty of helicity to be able to make some severe thunderstorms here. Lab straits are still up there at 8. Still got plenty of energy in the atmosphere. Let's actually double check that. I want to take a look at some surface storm relative helicity. And so you can see some of that's going off to the east here. Some of the helicity that it might be running into. Most unstable Cape. And the Cape is going to kind of, facet that whole entire thing right there. It's going to follow the entire same pattern pretty much. Surface-based Cape. Yeah, not too far off. Let's take a look at our SIGTOR. Alright, so our SIGTOR here, you can see these are always terribly difficult for people to really kind of understand, but once you see in some of these isolated areas here up over 1.0 at any point, then you start to see some elevated levels of SIGTOR. But you can see right up here in this area where we're getting some pretty big areas of significant tornado parameter. As these storms run into those areas, right on that border region of Oklahoma and Texas, I've seen a lot of tornadoes run out there and form there, and then go straight across Arkansas, or into Arkansas and Louisiana the same way. Alright, so we'll go back to composite reflectivity and take a look. Same thing with these QLCS systems. These are kind of dangerous and really, really unpredictable, because anywhere along here where you got these cells embedded in that line, you could have tornadoes forming inside that line that are isolated, hidden, well buried within the line, heavily rain wrapped, and they're happening at night. At this point, 10 p.m., it's already going to be dark. You're not going to see it. You know what I mean? Even even if the lightning flashes, the majority of the time here with a system like this is that it's going to be so rain wrapped you're not going to see it anyways. You're just going to see a wall of rain, and you're going to hear the wind. You'll hear the freight train if a tornado is embedded in it. You know what I mean? But please don't be looking for it, because it's a very dangerous situation with these kinds of storms that are going to be going on tomorrow night. All right, big, wide hooking structures in some of these hydrographs. So some of these tornadoes, honestly, I think could be on the larger side. All right, as we move into the unstable area of where we were getting some of the SIGTOR, we were also getting some of the heavier readings in helicity levels. It seems like there's kind of a pause zone here where these storms are really not lighting up the same way. It seems like there is a brief window of where these storms in this region here could get pretty severe. Let's take a look at our target area again. Alright, so right where we were looking, this is basically right where we're looking is in this 5% risk. So the National Weather Service has actually done this very, very well, where these storms are coming up into Texas, and then they're going and projecting right to that border region of Oklahoma through central Texas right there. And that's exactly what we're seeing right here, is in this line is our highest potential for the tornado threat, all the way up until about 9 o'clock. Now it seems like at 10 o'clock we do have segments in here that are going to start to look like they're weakening. You still have some segments here that are a little bit on the stronger side, but I do see some weakening in here. The helicity is starting to come down. The lapse rates are still up. That could be from diurnal heating as well. A lot of the daytime heating that was there is going to cause a very unstable air mass in that area, and that can linger over time. You know what I mean? That can linger overnight, actually, where that atmosphere is just charged up and it could just kind of linger there for a while. But then after we see this, I went back a frame instead of forward. After we see this and we start to see these cells kind of breaking up, and we start to see them start to weaken, still the potential for some severe thunderstorms, definitely. Lapse rates are coming down a little bit. Helicity is coming down as well. Alright, so by 10 o'clock, it looks like 11 o'clock, start at night, it does look like there's a lot of breaking up with these cells where they're starting to kind of lose their steam, and they're starting to, kind of come apart. Severe thunderstorms are definitely still going to be a factor. Hail makers are still going to be a factor as well, so there is still the chance for torrential rainfall, definitely some flooding with the ground being so saturated, trees and power lines coming down, some hail threat as well. You're going to have all that, and it's going to be very potential for all that after the potential for tornadoes. That's going to kind of stick around for a while. Okay, so let's go, let me see here, let's go back to, let me see here. Where are we going to go back to? Alright, we're going to go back to, right about tomorrow afternoon. And then we're going to pop this up to the north for our folks up in the Ohio Valley. Alright, your turn. Now, the Ohio Valley is definitely one area that we really do have to watch for. They've had some really significant weather systems over the last couple of years, especially with what just happened in Michigan. We're definitely watching this area pretty heavily because this time of year with the way the jet moves, you know what I mean? It has the potential to be pretty severe. So we're definitely checking that out. So hydrographs look pretty much the same as what we saw in the south. Big hooking structures. Storm Slinky's reading the hook as well. The ship is at 2.3, which is pretty substantial. That's pretty high for hailmakers. Supercell development before anything even gets going is at 11.4. So our winds are definitely there. Our instability, it looks like, is still kind of catching up a little bit, even though our lapse rates are up over 7. Alright, so let's go ahead and track this along. Alright, we're looking at 7 p.m. Tomorrow night. But let's track it backwards just to see what kind of prefrontal cells here that we're getting going. There isn't a whole lot going on in the Ohio Valley before that point. It looks like a couple of rain showers and little things going on. Let's take a look at some of the atmospherics here in Illinois. Okay, so I see what's happening here. We're actually going to go back a little bit more. I want to go back to kind of the morning hours. So if we look at our target areas here. So we're looking pretty much from the upper Missouri region going across into the Ohio Valley, into across Illinois and into Indiana. Maybe just a little corner of Iowa over here. Alright, so some of those regions are going to be affected. Alright, so we're looking pretty much from here all the way, over this kind of region right here. So let's go ahead and take a look. We're going to track it forward and see some of our first cells pop up right around here. It looks like. It could be that the atmosphere is just that unstable in northern Indiana. It doesn't look like it. So these are not the guys to worry about. Then we start to see some more cells popping up in northern Indiana. And it looks like as we continue on, so the wind barbs are not really that stretched out. So it looks like you're getting that kind of calming before the storm. I'm wondering what the cloud cover looks like at this point. Alright, so we do have cloud cover in this area here. However, you see these breaks in the clouds. We do have a little bit of breaks in the clouds here and there as they come across. There's a big, nice break in the clouds right there. Let's see how that... Yeah, see these big breaks in the clouds right here is where you're going to get a little bit of sunshine that's going to be shining through. Alright, so some of that with the temperatures the way they are. Let's take a look. Let's take a look at what our temperatures are here. Yeah, we're looking at 80 degrees. 80 degrees. Breaks in the clouds are not good for a storm setup like this. They're really not. Alright, we're going to go back to here. Let's go back to our composite reflectivity. Those breaks in the clouds is going to let a lot of sunshine and heat through, and that heat is going to supercharge the atmosphere for a really, really big, nasty storm. Alright, so off to the east is not where we're looking at. We're going to be looking at these cells right here. These are tiny looking cells, but they're all dashing off to the northeast. Yeah, that's what I was afraid of. These little tiny isolated cells, these are your tornado makers. So you can see that we have some really significant tornado parameter, SIGTOR. 11.7. The supercell development is kind of staying steady in that kind of range, which means that we're getting a plentiful, steady flow through of southerly winds that's carrying with it a lot of heat, a lot of moisture up into the Ohio Valley. Hail makers are really prominent up here at 2.1. A lot of possible damaging hail. Temperatures at 70s, 65 in dew points. Nice stable wind field. It looks like a pretty decent setup for tornadoes. Let's look at this northeast, this northern cell up here. Alright, off to the north, we're still getting the potential for some supercell development and hail makers, but not as big on the tornado scale. A lot of winds, though. Look at 68 to 77 knots of wind. So it can be a very, very windy day. This is one of those days where you don't really need a tornado to be able to have damage. Alright, you could still have damage with some of the straight line accompanying winds and some of the varying winds that it's going to be coming along with storms like this, of this size, of this magnitude. Even in those isolated severe storms, bringing with it 51 to 59 5-knot wind shear. You know what I mean? You could see, probably you could see a potential of anywhere from 75 to 85 mile an hour winds, or at least wind gusts, in some of these areas, being able to do some pretty significant damage. Definitely blow some debris around that it might pick off of a house here or two. That can cause injuries and cause damage. It can cause all kinds of mayhem. Alright, with this, there's a lot of helicity up here. Some of these cells might be going through a little bit of a power battle early in their development if they hadn't developed already at this point. You start to see a little bit of merging that's going on, choking out some of the other cells. And then they start building, and this is what happens. So, this probably absorbed one or two of those other smaller cells around it to become one big fat nasty supercell, and then it comes out with a sounding that's significant, really significant. The supercell jumped up to 20.1. On the data, that's ridiculous supercell development. So there's so much spin going on in the atmosphere right now, it would be so easy for a tornado to drop. Alright, so significant tornado parameters up. Look at this, 5.6. I mean, this is some of the highest rates that I had ever seen in soundings. You know what I mean? And I've seen pretty high for the most part. I've seen them, right way elevating the PDS TOR, you know what I mean, kind of hazard types. But this honestly, I think this should be labeled PDS TOR, because if this produces a tornado, it is going to be particularly dangerous. It really is. So our ship is at 2.3, so it's going to be dropping some really significant hail. Our most unstable cape is reading at 2,400 joules of cape, which is really substantial. That's high levels of instability. Sevens, our lapse rates are in the sevens. Effective inflow at 4.1. We're up in the fours of helicity. You know what I mean? So anywhere you're in the helicity levels of threes and fours, there's so much charged energy that's being able to ramp these storms up that it's just it's just unbelievable. This is the kind of setup that is, a nightmare, honestly. All right, hydrograph is looking with a really, really clear-cut, straightforward setup here. The structure is it's pretty textbook, to be honest with you. Really big, wide hooking structure. Anytime I see these big, wide hooking structures with these kinds of critical angles in them in the hydrographs, it makes me a little freaked out, because it tells me, some of these are going to be able to pack some really, really violent winds. Really violent winds. You could have these wide-based tornadoes. I mean, there's a possibility for a stovepipe or a wedge. You know what I mean? In these kinds of setups. Big, fat, beefy tornadoes that can stay on the ground for an hour. You know what I mean? And I hope, knock on wood, that is not the case tomorrow. Going into tomorrow night. But this is the reality of the situation based on what the HRR is showing me right now, and looking at their target area for what they put in here for the convection system. This is completely possible. It's completely a real. This is the reality of the situation, really. And that's just off that one tiny looking little cell right there. This guy here, this little teardrop that's in the middle of Illinois right now. These things, they spin off of the Missouri line. Half the time these cells in these storm systems, they come across this Missouri line right here. If anybody who's ever been to Missouri knows, I went to basic in Missouri when I was in the Army. I went in the summer. I was the dumbest person in the world to go to basic training for the U.S. Army in Missouri at Fort Leonard Wood in the summer. So it's like one of the hottest, most humid, wettest times of the year to go to Missouri. It's just hot and muggy and wet. So these storm systems come across that Missouri line, they run into Missouri, and there's so much buoyancy in that state because of the humidity alone that these storms just, it's like, it's like throwing a tissue at a fire. You just see it just turn into a ball of flame. And that's basically the same kind of thing for a storm moving into Missouri. It's just so much atmospheric instability there. These storms just, pretty much tickle themselves into becoming just monsters. All right, so, and that's kind of what we're seeing here, is that these storm systems do that. Look how in this next frame here, 7 p.m. tomorrow night, we see that storm that was absorbing all these other little storms. See, there's still one little storm system off to the south of it. Boom, it's gone. So this thing has been collecting up storm systems and absorbing them up, taking their helicity and their energy. I think I hit it too close. Let's go a little further out east. Alright, so after it absorbed that storm system, as when it went further east, the supercell development it actually kind of came down a little bit on that cell. So this is the indication right here that tells me, okay, it absorbed another storm cell. Now it destabilized a little bit. Now it's reorganizing because the SIGTOR is gone. SIGTOR is back down to 0. So that's what I was talking about with these storms. They absorb other storms, boom, it knocks them right down to 0. Now they got to build up and they got to start reorganizing all over again. So that's where you get the disturbance in the wind field that's down here close to the surface. You get a disturbance in the wind field and that convergence, and the hooking structures is still there in the hydrograph. The structure still looks good. You get a weakness in the wind field right around 4 kilometers, somewhere around there. All right, and that weakness is going to be part of that convergence and that coming together. Now it's got to reorganize. Let's see how long it takes. Helicity's gone. The energy is gone for the moment anyways. Let's take a look an hour later, going into 8 o'clock. All right, so this cell, I'm looking at the difference. It moved right into northern Indiana. Let's take a look just off to the southeast of it. All right, so it's coming apart, It probably moved out of what would be the unstable air mass. Let's take a look. Let's look at surface-based CAPE for right now. So it's in a little pocket. There's a little pocket of where it kind of came out of that air mass right there. The convection from the CAPE is not fueling it as much. But then back here, you see these big, huge, substantial CAPE levels and everything. So we're going to see some more development with that. Let's see how this kind of pans out. So this one kind of dies out a little bit, starts to destabilize. Then you got these big guys that are in full lines coming across here. You can see these big cells coming up here into the overnight hours going into Missouri. Now, just like I said, let's look at what the atmospherics say in Missouri right now. So minimal marginal tornado risks right here. You know what I mean? This is not little. This is not low end. I hate to say it. It says marginal tornado risk, which most people, if they look at this, oh, it's marginal tornado risk. It's no big deal. But when you look at the data and you know what you're looking for, look at our helicity levels. They're up at 3. And you know, they're in the 3 range. All right, you got already 65 in dew points out here, 73 degrees in temperatures. That's really hot. It's really muggy. And there's a lot of moisture being chucked around there. So there's enough instability in this area. I mean, this storm doesn't need a whole lot more to become severe. You know what I mean? The storms that are moving into Missouri. I mean, it's not going to take much with that kind of energy that's going on in the atmosphere. It's not going to take much at all. You got a substantial wind field right here. It's all organized. There's not a whole bunch of jumbling up and mixing in there, you know, causing all kinds of destabilization. Not at all. No. I mean, these storms are moving into Missouri, and they can get going really easily. These storms off here, you got a lot of isolated cells that are kind of embedded in almost a QCLS type of line of storms. You can see the supercell development on these are just ridiculous. Here at 23 in supercell development. SIGTOR is up at 1. Our SHIP is at 2.7. A lot of hail. A lot of hail that's going on. So a little bit of a power battle that's going on here. Well, it looks like the caps are maybe starting to they're starting to break, but maybe they're kind of holding out up until this point. So what I think is going to happen is this section up here and this section up here, I think, are going to converge into a line that's going to drag across the Ohio Valley. And I think that is a little bit of what we're going to see here in the future. All right, we're looking at 8 p.m. tomorrow. Let's look off to the western line. Whoa! Look at that. Wow. Okay, this is that western line behind these front cells right here. I was looking at this blob. I just popped it right off to the east of it. Oh, okay. So that one was kind of off a little bit. That was a little bit of an off reading there. Yeah, and then I hit it. This is southeast of that little cluster of cells. So when we look off to the southeast, we're getting almost 30 in supercell development. SIGTOR is up in the 4 range to CIN 6 range. That's a lot of significant tornado parameter. And our SHIP is at 3.6. So we're talking about really big, fat, nasty hail that can do a lot of damage. That can do damage, cause injuries, break windows out in cars. You know what I mean? It's you could possibly see that kind of hail in this kind of system here. A lot of energy that's going around with the 4s and the 4 range of helicity. Some of these soundings are, you know, in the recent years, some of these soundings that I'm seeing are unlike anything that I've seen in my 16 years of covering storms and forecasting storms. So some of these soundings are pretty nasty. All right, so when we get here to the lapse rates, we're reading in the 8 range now in lapse rates, which is ridiculously high. Our CAPE levels are pretty high. Here, 3,100 joules of CAPE, most unstable CAPE is reading. All right, so every type of possible hazard is possible with this storm. I'm talking about damaging wind shear. I'm talking about damaging big boy hail. I'm talking about really significant flooding, you know, flash flooding from horrible torrential rainfall. that could be possible. Even without a tornado, you're looking at veering winds all over the place. See, the thing is in the atmosphere with these storms on the ground, these storms, reach 50, 60,000 feet in the air. So, and what happens up at the top is kind of, rotating and filtering the whole entire thing down to the bottom of the storm. All right, so the wind can do different things, at different altitudes. That's why these soundings are made the way they are in this graph that's right here. All right, then you can see this here: 0, 1 kilometer, 3 kilometers, 6 kilometer, up, 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 up. It goes higher up into the atmosphere. So the wind, that's why we have these wind barbs here, because you can see there's different kinds of wind barbs at different altitudes. The wind could be doing different things and moving in different directions at different altitudes. And when you have that kind of thing going on, it can contribute to the supercell development. It can also contribute to dendritic growth zones, which is where snow and ice is made in the atmosphere. In this case, we're talking about hail coming down. All right, so when you talk about all these things and you put them in there and you look at a sounding like that, then you can say this is definitely a scenario where every single hazard type is possible. You know what I mean? So very, very abundant flooding, big boy hail, torrential rainfall. Lightning is probably going to be really, really substantial throughout all of this. You're going to have a lot of lightning. It's going to light the sky up like the 4th of July. Some of that lightning could be cloud to ground and positively charged. That is not the lightning that you want to be outside with, because if that hits you, it's like 20 million volts to your rear end, man. It's gonna light you up. All right, so you could have injuries. You could have very serious permanent injuries. You could have some of those injuries could be fatal. You know what I mean? So definitely a very dangerous storm that's coming at 8 o'clock around that time frame tomorrow night. Going from Iowa, we're looking in Iowa right now as it's getting into the Ohio Valley. This is just kind of north of our target zone, really, of the central point of the target zone. This whole entire area is target zone, but this is moving east into the Ohio Valley. These storms are coming. And as they move further east, we have yet, in this model anyway, to see if they are going to get more severe or if they're going to die down. I'm willing to bet that they're probably going to get more severe, at least until Indiana, where they might start to destabilize once they get out of the unstable environment there. Back here off to Missouri, then we got some more cells that are coming up northeast. Into our target area, so we're going to have to track those. All right, 9 p.m. Let's take a look at these cells that's coming through Missouri here. These are a little bit on the lower end than what we're seeing further off to the northeast, but still some substantial storms as they move into these areas. Yeah, these are not reading as severe. I think it's a little bit far west in the positioning as far as our target area. I think we have to look a little bit more into the Ohio Valley. Once these get further across Missouri into that border region of Illinois and Missouri, we're going to have to take a look at those cells again to see exactly what they do. Because once we get in here, then you start to get the trough in there, the jet comes into effect. You start to get all that big boy wind shear that's going on in there as far as the southerlies. Let's take a look at our wind shear and temperatures here. So our wind barbs are coming straight up from the south. You can see these big, huge temperatures right here, 70s, in temperatures. Up here, it looks like it's a little cooler, but we're getting a lot of moisture. Let's see here, 2-point wind barbs. All right, so with it bringing all that moisture, southerly wind up here, this is probably going to stretch a little bit further north than what might be described here. Because of that temperature, I can see the low pressure system is sitting right directly around here. You can see the wind actually bending around it. All right, so westerlies kind of dumping in with the southerlies. You can see where they're kind of mixing right here on this area where those westerlies are coming in, meeting with the southerlies, bringing a lot of heat, a lot of moisture into the low pressure system right there. All right, and that's what's kicking our storms up. Let's take a look at those far northern cells. So this is where they were at 8 o'clock. Then you can start to see them build, and you can see a lot of convergence that's going on in here. These cells are actually merging. All right, so after these merges start to happen, then you start to see a little bit of the quelling and destabilization in there, and that might be that recycling process that I was talking about, where these periodically, anyways, these cells are going to get to a little bit lower. All right, now that front line of storms, that bottom cell that's on the south end of it, just look to the southeast of it, and this is the kind of sounding that we're picking up here, which is pretty ugly. This is an ugly sounding right here. Most unstable CAPE at 2200 joules a CAPE. Our lapse rate's in the 7 range. Helicity's up in the 4 range. This is pretty substantial. 56 to 89 knots of wind shear. Anywhere in that kind of region where you could have straight line winds, that might be moving in upwards of 90 miles an hour at times in gusts. You know what I mean? You could have some of those really substantial wind gusts and wind shear in here, especially with some of the tornadic storms. That one is definitely tornadic. This is this big cell right here that we were looking at. Let's pop off a little bit further to the east to see what it's going to run into. All right, so even a little bit further east, the atmosphere is affected by that whole area. All right, so these storms kind of run in here and they run into this big unstable environment and they just get ramped up. These further northern storms, let's see if I can get in a nice little clear slot. All right, so this significant tornado, the supercell composite, excuse me, it just seems like it's kind of running off everywhere. Hail makers are all over the place. All of these storms could be producing some hail. All right, so let's hit you see this curvature in here. It's a really interesting feature, but in a storm like this, you see how it kind of curves, kind of like in a teardrop sort of thing off to the west right here. These little storms off to the west, and that curvature right there can be affected by the southern wind, by the southern advection that's coming up, blowing into these lines of storms. A lot of times it can get them kind of spinning up like that, but looks like we're getting a little bit of jumbling up here on the surface of the wind shear of the wind field. All right, still prevalent for hail, still got some instability there regardless of what the CAPE says. Oh, sorry, been doing this all day. I mean, still a pretty nice severe thunderstorm that's going to be coming off of this. However, on the back of the line here, it doesn't nearly look as severe as some of these storms that, especially this one right here. This storm cell right here has the potential to drop a pretty decent sized tornado. We're looking at 9 p.m. Tomorrow night. So it could be a nocturnal event, but this guy right here is definitely looking promising for tornadoes. And then you see this. And you can see that cell right there kind of spinning off in like a textbook sort of structure for a tornadic storm. You can see that little lip that kind of drapes off and sort of a thorn on the back right there. And that could be indicative of a hooking structure that would form maybe a hook echo on live radar. So that is a storm that we definitely have to keep an eye out for going into tomorrow night, because that one right there, that just tells me that you could get a nice little hooking structure right off of that with a forward flanking downdraft. This looks like an FFD right here. It's got a pretty good structure to it that might be indicative of a tornado being able to form tomorrow. If we look just to the southeast of that, I did pop a little bit of omega on that, but that's okay. But our supercell development is up quite a bit. Our STP is within target range. SHIP is at 1.0, so it's dropping hail. It's got a SIGTOR. It's got plenty of instability to it, and EHI levels are up at 2. I mean, that's more than enough than you need to drop a pretty decent-sized tornado. Now this one I popped just a little bit further to the east of the last position on the same cell, and this is the kind of reading that we're getting. Still popping a little bit of omega right here. That's okay though, but we're starting to get consistent readings that are pretty much substantiating the last sounding that I was looking at. All of our levels of helicity up in the 2 range. which is pretty much what the last sounding also told us. But now it's counting in a little bit more of the SIGTOR, as well as the supercell development. And this is telling me that this has a very massive potential to be able to drop tornadoes out of this cell right here, moving across northern Illinois, 10 o'clock at night. All right, this cell over here, this definitely has a potential for a pretty decent sized severe thunderstorm. I don't know how likely it would be to drop a tornado, but look at our winds here, 71 to 94 knots of wind shear is possible. So we do have really big, beefy wind shear here. Even if it isn't exactly organized wind shear, you still could have some wind gusts blowing things all over the place. Possibly in multiple directions depending on what the veering winds are doing. You know what I mean? So you can still have damage from that. You can still have some pretty substantial stuff out of that. Alright, so let's take a look an hour later. These storms off to the west, moving through Missouri, don't seem as concerning to me, even though they are moving into our target region. I think that our big boy storms off to the east are taking a lot of that energy with them. And I think behind it, they're kind of dying off. Rainstorms, thunderstorms back here, definitely some possible lightning. Torrential rainfall is still possible. Flash flooding alerts are definitely going to probably be out. Alright, so this guy right here, we're still watching this storm. You can see this line just above it. I'm actually going to pop our radar just a little bit further to the north here so we can see what's going on. Up on the top of it here, this is a lot of rain and thunderstorms up here. Not really expecting a whole lot of severe potential with these. Usually there isn't. If we, take a look at a sounding here in Michigan, you can see that the cold temperatures are going to be moving in there with the cold front, and this is going to cause a lot of that freezing rain, some of that snow to be accumulating. You can see we're reading a DGZ right now. This is the dendritic growth zone here where snow and ice is made in the atmosphere. So some of that's going to come down, and this is kind of one of these situations here where these storms, they produce hail and ice up here, but then as it falls and it comes to the earth, it's a little warmer down here, it starts to melt as it comes down. You know what I mean? And that's where you get that freezing rain kind of thing. Alright, so, but we're still tracking this cell, now moving into the border region, going into Indiana, northern Indiana. So let's hit it just a little far east here. Might be still going through a little bit of power battle with some of those isolated embedded cells in the line above it. You can still see it's reading, it's coming down, but it's still reading a pretty decent tornado outlook. It still has plenty of supercell development, still has plenty of SIGTOR. The instability is still really substantial. Alright, and our hydrographs still look good. Temperatures are coming down at 65 degrees, 64 in dew points. So as we get a little bit more of that cool air in there, that's causing some of that destabilization. Because where you get cool air, then you get dry atmosphere, you get dry temperatures. It gets drier, it starts to push a lot of that buoyancy and that moisture out of the area, it gets drier, and that chokes out a lot of these storms. Because heat and moisture is what you need. That's going to be like gas in a flame for a storm. You know what I mean? It's like gas in an engine, really, is a better analogy. So you choke the heat, and you choke the moisture, then you choke the storm. And it looks like that's kind of what's happening here, with some of these storms moving into this area, further off to the west. These were never really going in the first place. It looks like these storms off to the east kind of took the blunt force of a lot of the helicity. You still have some embedded cells in that line here, anywhere along that line of storms. If we go back a couple of frames here. Yeah, see, that storm up to the south was actually choking out a lot of these northern storms, but all of them had the potential still for hail. Off to the east, the midsection of that, severe thunderstorms. And then when we get into the, what are we looking at? We're looking at about 11 p.m. And these big isolated embedded cells in that line start to show some tornado potential. Alright, so supercell development, all of our accoutrement in this ingredient of tornado genesis is starting to come together. in these embedded cells right here in this section of line of storms. All right, moving across the upper Indiana region and lower bottom counties of Michigan. These areas here, definitely looking for some hazard types that are going to be, possible for some tornadoes. All right, now you see that bottom cell right here actually absorbed or converged somewhere in this line. I'm assuming into this notchy looking line of storms right here, where we have a lot of these embedded cells. These things are going to start to absorb storms around them and start to recharge, you regenerate. You see how it comes down a little bit? Comes down a little bit in severity, a little bit lower risk of a tornado, but we still have really beefy winds. We have enough helicity in the atmosphere. We've got plenty of energy. Lapse rates are up. Ship is up at 1.4. A lot of hail potential, that means. So we still have a pretty decent outlook to where some of these could still kind of linger in that severity. All right, going across Michigan, so we start to see it destabilize a little bit. That kind of tells me it's getting out of that air mass. It's getting out of that unstable environment and starting to choke it out with some of those colder temperatures, those drier environments, starting to choke those storms out. As these ones off to the back, you could get a little bit of training with these storms as they're moving into these regions, still kind of continuing off and trying to hold on to some of that severe potential. Off to the southwest of that line, these big storms down here, still pretty decent look for tornadoes. So this is a day, and this is going up into the midnight, 1 o'clock overnight kind of hours here, where you still could see some of these storms lingering on, at least severe thunderstorm possibility, maybe tornado potential. There's a very short window right here in that region of Illinois into Indiana, where we saw that one big cell back here. All right, this guy here, from pretty much this point, I would basically say from 7 p.m. on to about maybe 1 o'clock in the morning. That's really kind of your threshold of where you have the highest potential for some tornado development, is within that time. And that cell right here off to the southwest of that line of storms going from Illinois into Indiana has probably the highest potential to drop a tornado. I can't tell you honestly definitively if it will or not, but it definitely based on the data that we've seen from this cell, it has a massive potential to drop a pretty sizable tornado that can do some significant damage. This line of this storms here, right here, is 11 o'clock at night. Around that time, just prior to midnight, there's a line right here of embedded cells. These are all embedded cells, these little dots right here. If I zoom in on this, and you can see right here, boop, boop, there's 1, 2, 3, 4, 5. There's like 5 little dots in here. These are embedded cells in that line of storms, which means that they're hidden by heavy rain. All right, so hidden by heavy rain, and they could be bringing with them some really substantial winds, possibly some hidden embedded tornadoes in that line, at least for a little bit, until about an hour later. Then we start to get into that midnight going on to 1 o'clock region here. You can still see those embedded cells still trying to hang on with some of that notchy kind of feature on that line of storms right there, bringing with it some heavy winds, heavy torrential rainfall, and possibly an embedded cell, a spin-up tornado, a brief spin-up tornado at least, here or there, might travel on for a few miles and then dissipate as it gets out of that unstable environment. Because that's kind of what we're seeing here as it gets later on into that portion. You can still see still trying to hold on. Really notchy line right there. But when we look at the data starts to kind of show that it's starting to destabilize. Some of those cold temperatures are starting to cut it out. All right. And then it just kind of breaks up. You start to see severe thunderstorms still kind of moving around, trying to hold on to some severe tornado potential. A little bit on the lower end now. All right, but you still could get areas that have already been hit, and you could get them hit again with some of these storms training off to the west. All right, into if we look back here, we got storms moving from Missouri, from the Missouri region into Illinois. And like I said, you're going to have areas that are going to be hit again. All right, we're looking at the midnight, going into 1 o'clock, midnight 1 o'clock region right here. We start to see these storms coming out of Missouri, of northern Missouri, into the mid-Illinois range. And some of these storms now are showing the potential for some tornado development. So another training segment of storm is moving into Illinois at 1 o'clock, 2 o'clock, it looks like here, with the cells kind of going in there. It's not a humongous window for tornado potential on this reading, but it's still substantial enough to get at least one brief spin of tornado or two. Let's look off to the northeast here to see northeast what that big cell at the top is doing. Yeah, it's about the same thing, where the tornado potential is kind of going up and down. It's bobbing like a cork a little bit. You start to see these isolated cells. These things are bad because they leave a lot of potential for some extra tornadoes to form out. So this is unfortunately a day where you can see multiple tornadoes roll out in a very short span of time, going all the way from Missouri. If we look back here at Missouri, some of the cells off to the west are probably more likely going to be behind the cold front, where, yeah, see the temperatures are starting to get a little cooler as the cold air starts to push in, and that's going to be choking out some of the storms and bringing some of that stability back to the atmosphere. But ahead of that, moving into Illinois and moving into Indiana, then you start to see those storms still ramping through there, still have the potential to drop some tornadoes and some big beefy wind. Now the levels, the helicity levels, the potential for tornadoes is dropping. It's coming down, but it's coming down, kind of at a slow pace. It's like it's trying to still hang on. Just like storms are kind of like living beings that just try to grab at survival. Like any other organism in the universe here, you know what I mean? Storms are kind of the same way. They try to grab at their survival. They try to grab energy to survive. And that's kind of what we're seeing here. It's kind of like the last gasp, but they're trying to hang on. And they're starting to destabilize as they move into more stable environments. That cape levels are probably falling at this point. That's a surface-based, that's CIN. Surface-based cape. So you can start to see here the cape levels are coming down. They're still there. They're still there well enough with more than enough cape for these storms to become severe. But if we go back in the frames, let's take a look. So you can see how that cape was pretty extreme before with all that bluing here. All right, and as we get later on, the cape is actually dissipating and coming apart, and that's going to choke out those storms. All right, where you're going to see the cold front kind of coming in here. This is where that cold front's going to be featured, pushing out a lot of that heat and moisture and instability, and it's going to start bringing a lot of stability back to the atmosphere at this point. All right, moving into, what would it be here? That's Tuesday, moving into Wednesday. And then we have the day 3 outlook. Oh, that's the wrong one. And the day 3 outlook is still kind of up in the air. There's still a little bit of uncertainty with it, so I'm going to keep my eye on it. We haven't really got there yet. But we are looking at the potential for these storms to move into the southeast on the lower end, further into the northeastern portions of the United States tomorrow with these storms that are happening right now. As far as the live weather, we're still tracking that. It doesn't look as horrible as what we were assuming with a lot of the tornado potential. I'm surprised, actually, that no tornado warnings have come out yet. All right, but we are still tracking that. There is a little bit of very broad rotation going on, but it's meager at best, to be honest with you. And most of these storms are just kind of checking up with some really, really high levels of intensity with some wind shear and some heavy rainfall. That's definitely, and then obviously a lot of lightning. It's not as much lightning as I would initially have thought that would come out of a storm like this, but there is a lot of lightning potential that's happening here. All right, so just be mindful for some of the flooding risks, and definitely some of the trees and power lines that come down, because this is the southeast after all, and Birmingham, Alabama, these areas here going into Georgia, this land gets so freaking soaked and wet and soft. You just have trees coming right out. I used to live in northwest Georgia, and I've seen people that have gotten killed in houses and things like that from trees falling on their vehicles or on their houses. So definitely just keep an eye out to make sure your family is safe. Be in your safe place. Anything you need to do, you know what I mean? Just make sure that you know what's going on in your area. I wish everybody luck. I hope everybody stays safe, and stay tuned for this outlook that's going to be going into tomorrow, or rather Wednesday. So I'm going to go ahead and cover that on Wednesday, see what kind of threats that we're going to be seeing going into the Wednesday to Thursday outlook. Alrighty, so thank you very much for watching Severe Weather Network, and I hope that you guys come back and check me out again. Alrighty.